We're looking at another logarithm problem. We have log base 10, x to the 5th plus 1 raised to the 9th. So we have this exponent in here. We're going to have to deal with that. If you don't know log base rules, there is a video on it linked in the playlist below the like button. So do check that out. But now we're going to assume that we know the log base rules. And so we're going to just go down and solve through this.
In the previous video, it showed the rule that log of the base is 1 over ln of the base, so here it's 10, times, and then we do the ln of the numbers. Here we have log ln of 10 times ln x to the 5th plus 1 to the 9th power.
Remember though, this is she's new to this derivation stuff, but we should have a derivation sign here. That's part of the log rules, because we haven't derived this yet. This we leave alone. This needs to be derived now. So we have to derive this. So now let's look at the next line.
The next number is 1 over ln of 10. So as you can see, 1 over ln of 10 stays consistent until the very end because you don't really add it into this part of the equation just yet.
Yeah, we're not looking at this. This we don't really want to mess with. We're only deriving this now, so we're focusing on this. This is going to act as like a constant, so we don't need to touch it.
So here we're going to put the 9 exponent all the way to the front here, 9 ln x to the 5th plus 1. And the reason why I separated these two is now it's like a layer of an onion. Now we're going to focus on this one part before we work on the constant of the 9.
Before we go on to this next line, you have to know the rules of ln. And the rule of ln is that we have ln to a number, and this is going to turn into 1 over n, and then we're going to have to take the derivative of that number, similar to our log-based rules. And again, the videos on how to start with that is in the playlist linked below the like button.
So here we have 9, 1 over x to the 5th power plus 1, because that is our ln equals 1 over n, so this is our first part. We do not derive this at all. And then the second part, x to the 5th plus 1, we do derive this part. So here on the bottom, now we've derived the second parentheses, which is 5x to the 4th, because the 5 comes down, 5 minus 1 is 4, 5x to the 4th power. And then we bring the fraction right back down, 1x to the 5th power plus 1. Now we combine these two terms together and we get 5x plus 4, because you can only multiply onto the numerator, not the denominator, unless it's another fraction. You get 5x to the 4th power over x to the 5th plus 1. And now we work with our 9 constant. Now we multiply the 9 to the numerator, not the denominator once again, and we get 45x to the 4th over x to the 5th plus 1. Now we combine like terms with these two, and because this in this situation does not get multiplied to this bottom denominator, we're just going to put them in two separate parentheses, and then we get 45x to the 4th on the top.
It's not that this and this are like terms.
Is that like allowed on YouTube?
It's not like this and this are not like terms. They are and they aren't. They're like terms in the fact that this one and this one are both denominators. So that is why we're combining them, not because they have the same properties. The only reason why we're combining them is because this is the denominator as well as this being in the denominator.